This annual equivalent rate is like the real rate of interest, what you're actually getting on your savings if you deposit it in a bank. The bank might quote you 5%, but we want to find out how often we get paid during the year in terms of our interest. If it's only once a year, well then 5% will also become your 5%, your nominal will become your real rate of interest. If you get paid more than once a year from your deposits in your bank, well then your nominal rate of say 5% will be a slightly higher rate because you get that extra repayment. So in real terms, you could end up getting say 5.2%. And likewise, if you get paid more often, say monthly in terms of your interest from a bank, your real rate will go up slightly higher. So the real rate of interest here is just called the annual equivalent rate. That's all. Okay. Here we have three examples, three percentages, 12, 11, and 9. But they are quite different. But what we want to focus in on is how often we get paid on our savings throughout that year. And that's what compounded means. Okay, so compounded means it's going to be a slightly higher figure than the 12%, than the 11, and than the 9. Because in the first example, we're going to be paid quarterly, which is 4 times a year. The second, semi-annually, which is twice. And the third one, monthly, which is 12 times a year. Okay, so knowing that, we're going to look at a formula, and that's going to tell us where we should put those values in order to find out our real rate or our annual equivalent rate. That formula there will be given to you again in the exam if asked. Okay, and it tends to be kind of quite a popular question that's asked, not every year, but most years. Okay, so again, we have the OR and the N, and we're familiar with those. OR is your rate. In this case, it's our interest rate that we're being given, but N is going to be a little bit different here. Okay, N is not the number of years. N is actually the number of times within a year that we get paid on our interest, on our savings. Okay, so N in this first example would be a value of 4 because it's quarterly. Okay, so plugging all those values in, the 12% is your 0.12 divided by your 4. Okay, and when we add that onto your 1, okay, we get 1.03, and then to the power of 4. Again, that N is also your quarterly, or your 4 times a year. And that gives us the 1.1255. Subtract your 1 from it, so we'll get, and multiply it by 100 at the end, we'll get 12.55%. So you can see the nominal rate, which is 12%, but in real terms is slightly higher because we got paid on our interest 4 times throughout the year. Okay, if you only got paid once throughout the year, your 12% will be 12%. Because if you plug 1 in for N in that formula, it will become 1 plus 0.12 over 1 to the power of 1. That all just works out to be 12% at the very end anyway. Okay, so you can see the nominal is different to your real rate of interest if you get paid more. Your answer will always be slightly higher than what you're given. And we just repeat this another 2 times for the different rates of interest. So your 11% is compounded semi-annually or twice a year. Okay, again, putting 0.11 in for OR and 2 in for N, you will get your 1.055 to the power of 2, subtract your 1, and we will have a slightly higher answer than the 11%, which is here, 11.3. And the last one then is just a repeat of the previous 2. A new number, 9%, compounded monthly, this case, which in this N is going to be 12. And you have your 0.09 divided by your 12. Firstly, you add it onto your 1, which will give us your 1.0075. Get that to the power of 12, and we subtract 1 from it to give us your 9.381%. Again, you see a slightly higher rate of interest than the original 9%. So anything that's been paid more than once throughout the year on your savings will give you a slightly higher rate in real terms than the nominal rate or the original rate you were given at 9% or 11 or 12.